This video, we're going to identify properties and characteristics of rational numbers, meaning we're basically going over a few definitions here that are preliminaries before we get started talking about broader arithmetic and things with rational numbers. So the first definition here, the set of rational numbers is the set of numbers in the form of P over Q, where P and Q are integers and P and Q are integers and Q is not equal to 0. Okay. So that's why we talked about integers first, is it's the set of P over Q, where P and Q are elements of the integers. Now let's go ahead and look at the next definition. For the rational number P over Q, Q is called the denominator. And even though they don't ask this, because we're going to be talking about it later, P is called the numerator. It's going to be important for us to be able to call these things by their names. P over Q. This P over Q represents a division problem where Q is the divisor, P is the dividend, and the answer P over Q, this answer that you get is called the quotient. So you might hear us use the word quotient in a word problem, and we mean that you're supposed to do division. All right. See what our next definition is here. So this would be a fill in the blank with the appropriate word, phrase, or symbol. Rational numbers such as 11 over 4 and 3 over 2, for example, negative 3 over 2, are examples of, and the options here are equivalent fractions, mixed numbers, or improper fractions. They are improper fractions because 4 goes into 11 more than at least one time, right? So 1 and maybe some left over, or more than one time. It doesn't matter whether it's positive or negative, that 2 divides into 3 at least one time, and that makes it improper. A proper fraction has P less than Q. An improper fraction has P greater than or equal to Q. And it doesn't matter whether they're positive or negative numbers. I'm just talking about the absolute value here. So, all right. Let's look at our next question. Is this: the number 1/3 can be represented as what kind of decimal? Would it be a terminating decimal or a repeating decimal? So let's see. Let's do that division. 3 goes into 1.0, and I'll put some more zeros here. 3 goes into 1 0 times. Bring down. 3 goes into 10 3 times. 3 times 3 is 9, with a difference of 1. Bring down the 0. 3 goes into 10 3 times, and I think you can start to see a pattern forming here. that this is going to keep repeating. And so I'm just going to put dot, 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 ellipses to show that it keeps repeating. Another way that we can do that is that we can put a bar over top of the digit that's repeating. It's called a repeten bar. And that means that this 3 keeps on repeating forever and ever. So that's going to be a repeating decimal. Repeating was the blank that gets filled in. Okay, let's look at one more question here for this section. And I didn't write down section number and problem numbers, but these are like 5.3, numbers 1 through 9 odd. Okay. And the decimal number that I'm writing here, that I don't want to read to you because it will give the answer away. 7, which I'm going to underline here, the 7 right here is in the what position, what place value is it in? So place values are going to be really important in being able to read these numbers. We do not read this mathematically as 0.285714. That's not how we should read this. We should take into account decimal places, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So this is 285,714 millions. That's how we should read that number. But this 7 here is in the tenths, hundredths, thousandths, 10,000ths, DTHS, thousandths. Make sure it's heard clearly that you emphasize that there's a THS at the end of it. Thousandths, place value, 10,000ths. So that is the blank that we would fill in there. If it were on the other side of the decimal point, this would be units or ones, then tens, then hundreds, then thousands. We would want to be clear that people can hear the difference between us saying hundreds and hundredths, thousands and thousandths, millions and millionths, right? So we emphasize that when we say place values. It sounds kind of funny, but the math tutor or math teacher is going to really emphasize the THS if it's a decimal. And you should as well, so that people understand that you're talking about something that's less than 1, not something that's greater than 1. All right, that's it for this video. Next time we will come back and we will reduce fractions to lowest terms and talk about what that means. See you for the next video.